but not if you care about the climate. I know someone who doesn't fly because of the climate impact. And I live on an island where it's really hard to get anywhere without a plane. But did you know that only about half of the climate impacts from flying come from carbon dioxide? And that the biggest climate impact other than that could be eliminated for less than the cost of a stale sandwich that you'd buy on an airplane? Welcome to the 5th video in the Decarbonize series on aviation, where I talk about a climate intervention that I knew nothing about until recently. And once I learned about it, I knew I had to make this video. I've spoken about making airplanes more efficient, sustainable aviation fuels, electric and hydrogen-fueled planes, and offsets. And all of these are unlikely to significantly reduce the climate impact from aviation in the next 20 years. But there's a simple, cheap thing we can do that would make a significant difference that few people are talking about. And I want to be part of the movement that makes this real. And unlike most of my videos, I have a call to action for you at the end of it. So what is this magical thing? Contrails, or more fully, condensation trails. Have you noticed that when you look up behind a plane, sometimes you see a white cloud stretched in a line telling you where the plane has been? And sometimes you don't. That's the root of the intervention. But let's step back a bit and talk about clouds and climate. One of the biggest challenges of climate modelers is to predict under what condition clouds form. It's mainly, but not entirely, a function of humidity and temperature of the air in the upper atmosphere. Maybe you learned about the dew point in school, the temperature and humidity where the air can hold no more water. If the conditions reach the dew point, you can get clouds, fog, rain. Something usually happens. But what if the air is very clean, like it is in the upper atmosphere? It's hard for the individual molecules of water vapor to connect and form droplets of liquid water. If that's the case, the air is supersaturated with water vapor, and all you need to do is introduce what scientists call nucleation sites, and everyone else calls stuff, in the air, and you get droplets of liquid water and ice. You get enough of these, you get a cloud. That's how condensation trails form. The exhaust from the jet fuel includes water vapor and soot, which acts as nucleation sites. These combine with the cold air and a cloud forms. The first paper on the formation of contrails was written in 1919, and the process was pretty well understood by the 1940s. This plot of the Schmidt-Appelman criterion shows the conditions required to form contrails. Usually these clouds dissipate before the plane is beyond the horizon, but if the conditions are right, they can last for hours. So planes can cause clouds to form. Why should we care? Clouds are forming all the time, and we don't make a big deal about it. The reason we care is clouds can increase the greenhouse effect by blocking infrared light from leaving the Earth and radiating into the darkness of space, just like carbon dioxide, methane, and other greenhouse gases. Have you ever noticed that the night is warmer if it's cloudy? That the desert, where there are no clouds, can get very cold at night? That's because of the warming impact of clouds at night. Clouds also block sunlight from passing through the atmosphere during the day, as everyone in the west of Ireland, where I live, can tell you. So clouds can be warming or cooling. Generally, if they are formed during the day, it's a wash. But if they are formed in the evening or night, then they just trap heat without any balancing cooling. Studies suggest that most flights do not create a significant amount of warming, but up to 20% generate enough net warming to account for more than half of the warming caused by the carbon dioxide emitted when burning jet fuel in all of the flights. So if we could figure out a way to not generate clouds on a fraction of the flights, it would significantly reduce the global heating impact of the entire aviation sector. So the trick is to identify the planes where the long-lasting clouds will form at a time of day when they will create more heating than cooling, and to slightly modify their routes, probably flying slightly higher or lower so that the clouds don't form. Is that possible? The earliest effort to decrease the production of contrails was the military. If you're trying to penetrate enemy territory with bombers, a long white streak pointing to your plane isn't the stealthiest thing in the skies. But these efforts involved expensive fuel additives or other interventions that wouldn't be cost effective for commercial airlines. And they didn't focus on the cloud's climate impact. If you only focused on stopping contrails during the day, when the military would care the most, you could actually make things worse. Ideally, you would have a perfect meteorological database that knows the temperature and humidity at every location in the atmosphere. This would allow one to easily generate an additional constraint in the flight planning software that would send the planes on a route that avoided regions of contrail formation. And typically, this would just mean flying a little bit higher or lower, just like aircraft already do to avoid turbulence. A study suggested that the cost to change the routes of a small percentage of flights that would otherwise create long-lasting clouds would average out to less than $5 per person per flight when spread out over all flights, and reduce the climate impact of contrails by 80%. But our current meteorological tools aren't quite up to the task, but there's research working to improve our tools. An interesting project led by Google Research and Breakthrough Energy tried a shortcut. They developed an AI algorithm to detect contrails in satellite images and used that to predict the conditions where contrails would form. They then ran a test with American Airlines. Over the course of 70 flights, the pilots participating in the study reduced the number of contrails by 54% with minor changes to the routes. So are airlines doing anything to prevent the formation of contrails? Not yet. BlueLines.org has collected a list of research programs supported by a large number of airlines, and there are lots of interesting projects. But no airline is committed to implementing a contrail reduction program. More research is needed. Which flights should be moved to reduce impacts? Is it 1% or 20% of flights? We don't know. Will the cost be $5 per ticket or even less? We're not sure yet. But the science and tools are good enough to get started, to consider contrail reduction the same way they consider reducing turbulence. And we should start small, only making adjustments where we are most certain they would have a positive impact and low cost. But we know enough to get started now. So why aren't we? Here are my theories. The first reason is it will require them to change the way flight planning is done, considering a new constraint. Updating complex and critical systems like this is something airlines are loath to do. In 2022, a problem with Southwest's scheduling system caused the cancellation of 2,900 flights in a single day. So there's an understandable caution regarding an update to these critical systems. There's also a lack of understanding. Some research think the contrail issue might be more important than carbon dioxide generated by burning aviation fuel. Some think it's about half as important. All agree it's important. We have ideas on when and how to prevent the most impactful clouds, but there's still a lot of research needed to optimize our solutions. Any solution that is implemented will have to be flexible enough to incorporate what we learn as research is published. But the main reason airlines aren't doing anything is no one is making them do it. They'd rather talk about non-solutions like sustainable aviation fuel, which I talked about in this video, as not being scalable, or hydrogen in batteries, which don't exist. Half the companies I talked about a year ago are now bankrupt. They might encourage you to buy offsets, which are often worthless. The airlines like talking about these things because they don't require the airline to do anything but talk until these solutions become viable, which will be decades from now, if ever. So here's my call to action. Reach out to your favorite airline, one where you have a frequent flyer program, and ask them what they're doing to minimize contrails in the evening and at night. Send them a link to this video or one of the resources I have in the description. Share this video with every frequent flyer you know and ask them to watch it and send it to their favorite airline. There are few interventions that can make such a big difference so quickly and cheaply. And when airlines talk about sustainable aviation fuels and not contrails, you know that they're greenwashing, not really concerned with addressing climate change. So let's make sure that they know that you know that they're just greenwashing. I learned about the importance of contrails from Ritchie's wonderful newsletter, Sustainability by Numbers, and I encourage you to sign up. You'll find a link below in the description. I also recommend Contrails.org, which is a great resource for your effort to dig deeper and learn what's going on. And if you're interested in aviation and climate, you can check out my playlist on other ideas on reducing the climate impact of flying. And after watching that, you'll understand why I'm so excited about reducing contrails, a solution that can actually